Hello, students, and welcome to our algebra lesson today. We are going to start today with a do now about stressors, and we have a little chart we'll fill out. And today we're going to look at the powers of monomials and learn the power rule. Our essential question is, how does the power rule work? How do we know when to use the power rule? So think about those as we work. I would like you to complete the do now, complete the 2 pages, it's 20 problems, complete the exit ticket, and homework is homework number 2, powers of monomials and geometric applications. Remember, the last day to turn in any Unit 5 makeup work is Monday. But also remember that we've got the Pi Day contest coming up, and extra credit is going to be given for your participation. So we can help you with that. So we'll come back to our exit ticket in a minute. But for now, let's look at our do now. Stress may come from things we cannot control, but we can control how we respond to those things, our response. So let's complete the chart. So we cannot control the amount of schoolwork or homework a teacher assigns, but we can control, let's say, how we plan our time. We can control scheduling our homework time. And we can also control things like being more familiar with the material so that homework isn't as hard. We can also control getting extra help. So think about what you can control when stressors come to you. Also, let's think of another example. We cannot control the number of credits needed for graduation, but you can control the fact that you pass every class so that it doesn't take you longer. If you don't pass a class, you don't earn that credit for graduation. So you can control that by working as hard as you can in school. So I want you to think about that, and I want you to fill in the chart. And if you have any other thoughts, please put them here. So powers of monomials. This is the power rule. To raise a monomial to a power, we use the power rule, which states that when we have x raised to the a power, and then we multiply that by the b power, what we have is x to the a times b power. And let's look at how that works. So we have x to the second raised to the 5th power. So that would be x to the second times 5, which would be x to the 10th power. If we have m to the 7th and n to the 4th, that would be m to the 7th times 4, n to the 4 times 4, which would be m to the 28th, n to the 16th power. Okay, if we have c d to the 2nd power raised to the 3rd power, this is one of our invisible ones. Okay, every number has an invisible exponent of 1 unless it has another exponent. So that would be c to the 1 times 3 power and d to the 2 times 3 power, which would be c to the 3rd, d to the 6th power. Now, let's look at when we have coefficients. When we have coefficients, we raise the coefficient to the given power, simplify the variables with the power rule, and then we're done. So let's take a look at that. So we've got this coefficient of 5. So 5 squared is 25. And we have x to the 7 times 2, which is 14th power. We have 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2. That's 32. Then we have x, 2 times 5 to the 10th power, y, 1 times 5 to the 5th power. Number 6, we have -2, p to the 4th, q to the 6th, and all of that is raised to the second power. So -2 times -2, remember that becomes a +4. We have p to the 4 times 2, 8th power, q to the 6 times 2, 12th power. Number 7, -4, c to the 3rd power, d to the 4th power, all of that raised to the 4th power. So -4 times -4 times -4 times -4 becomes positive 256. And then c to the 12th power, d to the 16th power. So try the next two and then come back to the video. So here we have -3 to the 3rd power. So -3 times -3 is +9. +9 times -3 is -27. X to the 2 times 3 power. And then with a fraction, we have 1/2 times 1/2 times 1/2, which is 1/8. A to the 3 times 3 is 9th power. B to the 4 times 3 is 12th power. C to the 5 times 3, 15th power. Now let's do a little mixed practice. So in number 10, we have x to the 3rd, y to the 3rd raised to the 3rd power times xy squared. And notice in the second expression that only the y is squared, not the x. So that would be x, 3 times 3 is 9, y, 3 times 3 is 9, times xy squared. Now we have to apply the product rule. So x times x, well, this is an invisible exponent of 1. Let's change the color. We have an invisible exponent of 1 here. So it's x, 9 plus 1, x to the 10th power, y, 9 plus 2 to the 11th power. That's our final answer. Number 11, a to the 3rd times the quantity of -a squared b, all of that raised to the 4th power. So that would be a to the 3rd times, let's do the parentheses. So we have -a times -a times -a times -a. Okay, -a to the 2nd power raised to the 4th power is going to be a. So -a times -a is a. Let's get that right down. Times -a is +a. Now we're going to raise that to the 4th power. So 2 times 4 is 8. So that would be a to the 8th power and b to the 4th power. Now we're going to multiply the a's. So we add the exponents. That would be a, and I think use another color here. So that would be a, 3 plus 8 is 11, b to the 4th. Okay, number 12, -2ab squared, all of that raised to the 2nd power, times 3a squared b, all of that raised to the 2nd power. So -2 squared is +4. A squared is a to the 1st power times a to the 2nd power, so that would be a squared. B squared, 2 times 2 is 4, times 3 times 3 is 9. A squared becomes a, 2 times 2, a to the 4th, and b to the 2nd power. Now we have to finish up. I'll change the color. So 4 times 9 is 36. And then we have A, 2 plus 4 is 6. B, 4 plus 2 is 6. And that's our final answer. Number 13. So let's start with the first expression, 6a squared b raised to the third power. So that would be 6 times 6 times 6, which is 216. A, 2 times 3 is 6. B, 1 times 3 is 3. Times, now 1/3 times 1/3 is 1/9. And a squared, b squared, c squared. Now let's multiply all of this together. 216 times 1/9 is 24. And a to the 6th times a squared is a to the 8th. B to the 3rd times b squared is b to the 5th. And then we have that c squared. That's our final answer. Okay, number 14. We have 2a squared raised to the third power plus a to the fourth power multiplied by 3a squared. So left to right. So 2 to the third power is 8. So we took care of that. A, 2 times 3 to the sixth power plus, we have an invisible 1 here. So 1 times 3 is 3. And a to the fourth times a to the second is a to the sixth power. And look what happens. We can combine like terms. We have 8a to the sixth power plus 3a to the sixth power, which is 11a to the sixth power. And then number 12, 3x to the third power, y, all of that raised to the fourth power, minus 7x to the fifth power, y, all of that raised to the second power, times x squared, y squared. Okay, let's work left to right, and let's just work carefully. So 3 to the fourth power is 81. X to the third times 4, so that's x to the 12th power, y to the fourth power, minus, we've got 7 squared, that's 49, and that would be x, 5 times 2 to the 10th power, y to the second power, times x squared, y squared. Now let's work from left to right. Remember, we have to, according to the order of operations, we have to multiply before we can subtract. So we have 81x to the 12th power, y to the fourth power, minus, and we've got this 49, then x to the 10th times x squared, so it's this times this. That would be x to the 12th. Y squared times y squared is y to the 4th. So now we have like terms that we can easily subtract these monomials. So 81 minus 49 is 32, and that's x to the 12th power, y to the 4th power. So now we have some geometric applications, and knowing how to work with these monomials and these powers is really helpful for that. Now remember, the perimeter of a rectangle is 2 times the length plus 2 times the width. That's important because we have 4 sides to this rectangle. So we have the long side, the length is 12x, the width is 5x squared. So the perimeter equals, use P for perimeter, 2 times 12x plus 2 times 5x squared. Okay, and let's simplify that. 2 times 12 is 24x plus 2 times 5, 10x squared, and 24, well, that's all we can do for the perimeter. Now, they've also asked us to find the area. Now, area is length times width. So now, A for area, we're going to multiply 12x times 5x squared. We'll use those product rules. So 12 times 5 is 60, and x to the first power times x to the second power is x to the third power. So that's our area. Number 17, we've got a triangle with an altitude of 4a squared b, a hypotenuse of 10a squared b, and a base of 3ab. Now, first we need to find the perimeter that's around the outside. So we're going to add these together. So the perimeter will be, we'll start with the 4a squared b plus the 10a squared b plus 3ab. Okay, so we add those up, 4 plus 10. We cannot add the third term because it's not a like term, but we can add the second and first term together. So 4 plus 10 is 14a squared b. So that takes care of these two. And then we still have that plus 3ab. And that is as much as we can do in terms of simplifying that. Now the area. So let's look at the area of a triangle is 1/2 length time, 1/2 length, well, base times hypotenuse. So we could call it the height. So let's say 1/2 height times base. So this 4ab is the height and 3ab is the base. So 1/2, use parentheses, 4a squared b times 3ab. Now we can multiply these unlike terms, that's fine. So 4 times 3 is 12, and half of 12 is 6. So that takes care of our numbers. Now let's work with the variables. A, 2 plus 1 is 3. B, 1 plus 1 is 2. And 6a to the third b squared is the area. So number 18, we're asked to assume that the triangle below is equilateral. And we're asked to find the perimeter and the area. So the perimeter, we're going to start with, if it's equilateral, then each side of the triangle is the same as 20m to the third, n to the fifth. Okay, so we can assume all these sides are the same size. So we're just going to take that and multiply it by 3. So it would be 3 times, put it in parentheses, 20m third n. And when we simplify that, 20 times 3 is 60. And that still would be m to the third, n to the fifth. And that is the perimeter. Now let's do the area. Now they gave us the height. Sometimes we call this the altitude. You'll learn that in geometry, of 4mn to the fifth. So we're going to use the same formula, 1/2 base times height, that we used in the last problem. So it would be 1/2 and it would be 20 m to the third n to the fifth times that 4 mn to the fifth. So 20 times 4 is 80, and half of 80 is 40. So that takes care of our numbers. And the m is 3 plus the invisible 1, which is 4. And the n is 5 plus 5, 10. And that's our final answer. And number 19, we're only asked for 19 and 20 to find the area of the figure. So if we're going to find the area, we need to understand what the formula is for area. Well, the area is going to be, let's see, we have a rectangle here, and the height is 2xy. So here's the way I would handle this. There's a couple of ways you could handle this, but the way I would handle this is I would do 1/2 of 4x squared y plus 7x squared y, and then I would multiply that times 2x squared y. So let's lay that out. Clean up my drawing a little bit. So 1/2, and I'm going to add the top and the bottom. Multiply that by 2xy. Because to get this trapezoid, to find the area, we want to do 1/2 the short side plus the long side multiplied by this altitude here. So that's the formula that we're working with. There's a couple other ways you could have done this problem, but that's the way I do it. So let's first, let's combine inside the first set of parentheses. So we have 1/2. So 4 plus 7 is 11x squared y multiplied by 2xy. And 11 times 2 is 22. 22 multiplied by 1/2 is 11. And x squared times x is x. 2 plus 1 is 3. And y times y is y squared. And that's our final answer. And then number 20, the area of the circle, and it's so fitting for Pi Day. The area of a circle is pi r squared. So we've got pi, let's put area equals, and the radius is 3xy to the third, and then we need to square that. So that will equal, and you can just use pi. You don't have to use 3.14 on your calculator. So let's not forget to square our 3. So we have our pi. It's a convention generally to put your constant or your coefficient in front of pi. So 3 squared is 9, and we've got our pi. Remember, multiplication is commutative, so it doesn't matter. The order doesn't matter, and the grouping doesn't matter. So it's commutative and associative. So x 1 times 2 is x to the second power. y 3 times 2 is y to the 6th power. So the area of this circle is 9 pi x squared y6. So let's go back to our exit ticket. So 2 examples of the power rule. How about I use my initial, g to the 3rd power, because my birthday is on June 3rd, raised to, let's say, the 10th power would equal g to the 3 times 10 power, which would equal g to the 30th power. Now let's do this with numbers. Let's just save the numbers for later. Let's just do some more letters. Let's do r to the 5th power raised to the 2nd power, and that would equal r5 times 2, which would equal r to the 10th power. Now you can put your own examples there, but make sure you put a couple of examples so that we know you understand that with the power rule, you're multiplying the exponents. So again, don't forget Pi Day. Don't forget to work hard. Show all your work. Do your homework tonight. And if you do that, you know you'll be great.